Svelte, the cool kid on the block everybody is talking about. It took the world by storm in 2019 and it quickly got on the top of a lot of JavaScript charts for both things such as performance and community interest. In this video, we'll spend some time looking into what Svelte has to offer and how its fundamental concepts differ from some of the other very popular frameworks such as React or Vue. To put things in context, I've been involved in front-end development for more than 10 years now. During this time, I worked with both older tools such as jQuery, AngularJS or Knockout.js, and also with some of the current fan favorites such as Angular, React or Vue. I'm usually a fairly late adopter, which I think is a healthy approach in the front-end framework space, and I value pragmatic approaches, strong community support, and a less is more mindset when choosing the tools for a new project. For the past 3 years, React has been the de facto go-to library for me due to its simplicity and reliability, so my main goal here is to figure out if Svelte is a realistic alternative in my day-to-day work moving forward. We'll start by taking a quick look at the project setup. One of the most important features I'm expecting every library to have at this point is first-class support for TypeScript. I'm usually reluctant to add a lot of third-party libraries dependencies to a project, and I was also a fairly late adopter of TypeScript since I believed for a long time that ECMAScript 6 and its subsequent yearly releases will offer all the tools needed to reliably develop large-scale front-end software. However, after being involved in a couple of large Angular projects, I consider TypeScript a must-have in any project now because of the enhanced development experience. Setting things up is remarkably quick and easy. Note that this part of the video runs at normal speed, so all in all it takes less than half a minute to have things configured and installed using a TypeScript template. Of course, good CLI support is pretty much the norm in the industry now, but I was still surprised by the small number of dependencies a basic Svelte project needs. This makes sense, however, since Svelte is known for its concise codebase and small bundle sizes. With the setup out of the way, it's time now to take a look at the project structure. Note that I'm using the VS Code IDE for this, since at the moment it provides the best support for Svelte projects. Again, things are pretty familiar here. The index.html file is the main entry point in our app. Besides the usual meta and script tags you would want to add here, it also loads a main.ts file, which will start the execution of all the generated JavaScript code and will update the DOM accordingly. Inside the main TypeScript file, the app component is loaded and is rendered in a root HTML element, which has the app ID. We are finally getting to the app.svelte file, and this is how a Svelte component looks like. Just like Vue.js, the approach here is to have the TypeScript code, the HTML template, and the CSS rules all in the same file. As you might know, there are multiple schools of thought regarding code structure. You have Angular's approach to separate the TypeScript, the template, and the CSS in different files, and the React's approach to mix JavaScript with JSX in components. Honestly, at this point, I don't really care about what approach we are using as long as it gets the job done, so you should do the same. We'll jump right in, and for a lack of a better idea, we'll build the usual basic to-do app. For now, we'll simulate fetching some tasks from an API. To do this, I already prepared some boilerplate code, so we can focus only on the interesting bits. The fetchTasks method returns a list of demo tasks we can work with. Inside the script tag of the app.svelte file, we'll first declare a tasks empty list. Then, we'll call the fetch method, which returns a promise. This is the basic example of the front-end client code communicating with the backend API. When the server response is received, the promise is resolved and we are assigning the result to the tasks variable. Inside the main tag, we can work on some basic templating. For those used with some of the older tools, Svelte rendering declarations resemble the handlebars approach a bit. So, instead of JSX or tag attributes, it offers independent each and if blocks you can use between curly braces. Again, this is one of those cases where the opinions of the framework author shouldn't really bother you as long as the learning curve is not too steep. So, we'll iterate over the tasks list using an each block, and we'll just display the tasks names in a simple list for now. This is probably a good time to mention another interesting decision taken by Svelte: the lack of a virtual DOM. When React entered the scene back in 2013, the virtual DOM was considered a breakthrough in the UI rendering space. It was beating the previous DOM diffing strategies by far in all speed metrics, and for a while it became the de facto approach for figuring out how the DOM needs to be updated. In the past couple of years, the community has figured out better ways to solve the rendering problem. New tools such as Angular's Ivy engine, which uses a variation called the incremental DOM, or Svelte direct DOM update approach turn out to be both faster and more lightweight than the previous virtual DOM. When it comes to event handling, there isn't anything out of the ordinary. You can easily register handlers for all browser events and point to functions declared in the script tag. Inside the add random task function, we'll add a new random task to the list. Keep in mind that Svelte, just like Vue, relies on assignments to figure out what changed and how the DOM needs to be updated. Therefore, whenever adding or removing elements from a list, use the assignment and the spread operator, since pushing or pulling from the array will not trigger UI changes. A nice related feature here are the event modifiers. Using the pipe operator, you can alter the behavior of the events. Besides the usual prevent default and stop propagation, you can do useful things such as triggering the event only once. Let's quickly touch on the styling topic, even though there is nothing of particular interest here. You can add your styling rules in this file and they will be automatically scoped to the current component. It's time now to discuss one of the coolest features of Svelte: the reactive statements. Using the JS label syntax, we can mark any top-level statement as reactive. This means that, after the component updates, these statements will run automatically, so you'll end up with code which is truly reactive. No more observables, hooks or listeners. Truly reactive. It's also important to mention that Svelte does a lot of its internal heavy lifting at the compile time. This results in faster and better performing production apps, since less framework code needs to be executed at runtime. Before moving forward, we need to discuss keyed each blocks. Also, let's fix this little typo, since each element inside the tasks list should be assigned to a variable called task. As a good practice, you should always add a unique key for each of the elements rendered in each block. This is pretty much the norm in all libraries, since it helps the diffing algorithm uniquely identify each DOM element. As a different example, the React linter shows a warning flag whenever you are forgetting to add a key, for instance, so remember to do this in Svelte as well. Of course, all the keys need to be unique. Next, we'll take a look at the fundamental building block of any user interface: the component. Let's create a new Svelte file called taskline. In here, we'll add the 3 code blocks, one for the TypeScript code, one for the template, and one for the styling. Next, we'll want our component to be able to receive a task object as a property. We can easily do this by declaring and exporting a variable. The export keyword is the one marking the field as a property. I know this is not the most intuitive approach, but at least it's straightforward. Inside the template area, we'll just print the task name and task description for now. Then we'll jump back into the main app file to refactor the previous code and start using our component. Inside each block, we'll pass the objects from our task list as parameters, and the preview will now be updated accordingly on the left-hand side. Notice that our component requires a task property in order to know what to render. A nice little trick here is to define the property default value. This will ensure that your UI will render some sort of meaningful content, even if some of the data passed to the component might be either missing or corrupted. Of course, we need to add some interactivity on our page. For our demo, we'll just add a few buttons which will allow us to change the task status. The interesting scenario here is to see how a child component can modify the state of the parent component, since the task entity received by the task line component is part of the tasks list defined in the main app component. To visually show which is the task status, we are adding an active class to the appropriate button. Svelte templating engine is straightforward, so anything defined between curly braces is a JavaScript statement which will be evaluated accordingly at runtime. Registering event handlers is also easy, and as we've seen earlier, the syntax resembles Vue.js's approach. Again, nothing too fancy or out of the ordinary regarding all this. For now, we'll just print the new status value in the console, and we'll get back to this in a second to see how we can notify the parent component about the change. In the meantime, let's add the rest of the status buttons quickly. For this, we'll iterate over the task status in num keys, and, using the each block, we'll generate the needed HTML in a more concise manner. This is the proof I needed to see that the templating system is flexible enough. I'm doing some quick refactoring and adding some hard-coded labels to get through the scenario quickly. In real-life projects, you might want to structure your code a bit more cleanly if you are a strong believer in a rigorous separation of concerns approach. Based on my experience, all large codebases end up breaking some of the architecture decisions defined in the early stages, so my advice for you is to write clean, concise code, but focus more on the solutions you are coming up with instead of taking project structure rules to an extreme. Finally, I'm adding some styling rules so that the UI looks just a little bit better, and now we are ready to look into a more interesting scenario. communication and data exchange between components. We've seen already that components can pass down the component tree data as properties, so let's see now how child components can pass information up the chain. If you have experience with other popular frameworks, you probably know a couple of different ways to solve this problem. Svelte follows the most popular one and allows developers to emit custom events, which can be caught and handled higher in the component tree. Honestly, I prefer this solution compared to React's approach to pass events handlers as properties. Using the on keyword in the parent component, we can easily catch any custom event. Notice that, since we are using TypeScript, we get useful coding suggestions. All in all, I find all this pretty straightforward. If you have some basic experience with recent front-end frameworks, I believe you'll be able to pick up Svelte's basics in no time. In the event handler, we are getting the updated task, and we now need to also propagate this update in the task list. Without correctly updating the list, no DOM changes will be triggered. As mentioned earlier, Svelte triggers DOM updates when a change detection happens, and in order to trigger such a detection, we need to reassign the task's variable. I agree this code looks a little bit weird and it might not make sense if you are not familiar with how things such as mutability, objects and references are working in JavaScript. There might also be more elegant ways to do this assignment using a spread operator or a third-party library, but the issue at hand remains. Make sure to do an assignment on your arrays and objects to trigger UI updates. Another important aspect of single-page applications is handling user input. As some of you might know, Angular, for example, really excels at this with its reactive forms implementation, but most big frameworks have good support for this. We'll work on a small form that allows us to create a new task, but I want to quickly discuss another very important concept first: the routing. Frameworks have various approaches for this, and they either come with native routing support or with good community alternatives. If you want routing support from the official Svelte team, you'll need to use a library built on top of it, such as Sapper or SvelteKit. In our case, I will use one of the most popular routing libraries provided by the community, Svelte Navigator. Its approach is very similar to all other routing solutions, regardless of the main framework you are using. We'll start by wrapping the main content of our app in a router component. Next, we can split the content into sections using the route component and decide what elements will be displayed on the page based on the active URL path. Besides the route path, we'll also add a route mapping which will allow us to navigate to a different page in order to create a new task. I'm just adding a placeholder here for now, but we'll work on a new component for all these in just a second. And finally, we'll be using the link component to correctly navigate between the previously defined routes. And this is pretty much the gist of routing. Of course, Svelte Navigator offers more capabilities than what we looked at, so I'm certain it will cover all the use cases you'll run into in a real-life scenario. It's time now to create a new component which will handle some user input. We'll map this to the /new path, and later we'll save the data in a Svelte store. I'm also adding some already created style rules, and now we are ready to go. This is also probably a good time to quickly touch on the one-way versus two-way data binding topic. This debate was pretty heated for a while, since the flow of data through an application can be the cause of a lot of bugs. Libraries like React decided to only allow one-way binding by default, while Angular, for instance, gives you the option to decide between the two alternatives. Svelte is also flexible enough to let you choose the option you want, and we'll go with the two-way binding for our experiment. In real projects, however, the one-way binding might be more appropriate and is the encouraged way of doing things, since, all things considered, helps you maintain a more clear data flow through the app. Using the bind value tag, we can link the user input to the title and the description variables. As you would expect, whenever the data inside the element changes, the values of the variables will change as well. To quickly test this, we'll simply print the values when the save button is pressed. A special binding I'd like to quickly mention here is the bind this. Even though Svelte manages DOM updates, there are scenarios where you might need a reference of a specific DOM node element. This isn't a new concept, and all frameworks enable such a feature in one way or the other. Using a $label block, we can run a side effect whenever the title changes. Think of this as the useEffect hook in React, but without the need to specify a dependency array. For demo purposes, we'll manually change the background of the input whenever the title is too short. However, a much better approach would be to use Svelte's special class directive. This is extremely flexible and useful. While Angular and Vue offer similar support, a more powerful way to handle class names in React is something I was really missing. So small things like this, combined with the overall simplicity and the undeniable performance, makes Svelte a real winner in my opinion. The final important concept I want to look at in Svelte is state management. Again, a topic that spawns heated debates, a lot of conflicting opinions, and even more related libraries and proposed solutions. Svelte acknowledges that in some cases you need to access data in multiple unrelated components and provide something called a store out of the box. We'll start by adding a store.ts file where we'll define our tasks list as a writable store. Next, in the main app component, we'll import the store and refactor a bit our code. The store object exposes a couple of methods like subscribe, which allows you to listen for store changes and react accordingly. For now, we'll assign the store value to a local tasks_val variable. There is a cleaner way to do this and we'll look at it in a second. Before that, let's fetch the existing tasks and add them to the store. Just like all other frameworks, Svelte allows you to run code at different times in the component lifecycle. Usually, you'll fetch the needed data only once when the component is mounted. Remember that the task variable is now a store object which wraps the task's DTO array, so it will not expose the usual array methods such as length or find. So, of course, we need to refactor the rest of the code to use the local value instead. Now that we have the store in place and we are rendering its data in the tasks list, we can push a new task into the store via the inputs we created earlier. We'll get back into the new tasks page component and update the save method. The store object exposes an update method which accepts a callback as an argument. In that callback we gain access to the previous store value, so it's very easy for us to push a new object in the array using the spread operator. As you probably recall, we need the unique ID for each entry in the list, so we'll use the current timestamp since we don't really need something too fancy. And these are all the basics you need to know in order to use stores. Most of the community is moving to lighter state management solutions with libraries such as ngxs, Akita or Recoil. Svelte follows the same pattern and provides a very easy to use solution in this case. It's also worth mentioning that, just like React, they offer a context API for seamless component communication, so it's up to you to decide which solution better fits your needs. The last thing I want to show you is an enhanced approach of working with stores. You might remember that earlier we created a subscription in order to keep a local task variable up to date. The rule of thumb is that whenever you are subscribing to something, you should also unsubscribe to avoid memory leaks. We could do this in the onDestroy lifecycle method, but this is not a great solution. Instead, Svelte allows you to use the $sign to auto-subscribe to a store. This simplifies greatly the way in which we can work with the store values and will also handle the unsubscribe call for us. At this point, I feel like I look at all the core functionality I would need to start building things with Svelte in a reliable manner. However, I advise you to take a look at their documentation, since I did not get the chance to mention quite a lot of other features they are offering. All in all, I'm impressed by what Svelte has to offer. It is not going out of its way to rethink things that are already working, and the new approaches it comes up with are really a game changer in my opinion. Would I use it in production now? It depends. I think it's a great fit for small lean development teams with a lot of front-end experience under their belt. For large teams or enterprise software, it might be a tough sale, especially if there aren't enough Svelte experienced developers in the local market. If you've made it this far, thank you for your time and consider liking this video and subscribing to the channel. Thanks!